In section 2 of chapter 9, we're going to start studying what are called inverse functions. Now, I will forewarn you, this chapter will seem a little disjoint. It kind of feels like halfway through this chapter, we are going to ditch the idea of inverses and go towards another topic. In reality, we aren't. We're going to bridge two topics together. It's just that the first half of this chapter is over inverses, the second half is over another topic, and then chapter 10 is when we're going to merge those two ideas together. Without further ado, let's do inverse functions. First off, here's some guiding questions to get you in the mindset of how to understand, interact with, and deal with inverse functions. First, we got to ask ourselves, what does inverse mean? Inverse mathematically means two things that do the opposite. So, for example, question 2 is saying, what are some inverse operations that we have? Things like addition and subtraction are inverse operations. Addition moves forward on the number line, subtraction makes you move backwards. Another set of inverse operations are multiplication and division. And then a third type would be something like squaring and square rooting. These are inverse operations. These are things that undo each other. What we're going to do right now is we're going to develop the idea of what does it mean to be an inverse function. So inverse operations undo one another. Inverse operations always come in pairs. Inverse functions also do a similar thing. So inverse functions are what we're going to be focusing on right now. And we're going to be looking at what do they look like algebraically, what they look like graphically, and how to compute their values. All right, first, I've got to really focus on the notation because inverses have very specific notation that if you are not primed for, it is very, very easy for you to think it's something else. So if I give you a function that I will call f of x, then its inverse function, a function that will undo that one, just like addition and subtraction undo one another, will be written the following way. F inverse of x. This -1 is not a power. If you ever want to write a power for a function, you put it over here. Like if I wanted to write the third power, I put a 3 right there. That would be me telling me I want to cube that function f. You do not put exponents in the space between the function's name and the variable. This location is something that we reserve to mean it's going to be some form of variation of the original function f. Now in Algebra 2, it's primarily used for the inverse function. It's primarily f inverse, so -1, of x. Later on in subsequent math classes, different symbols will start to go there, and each one means something different. This is just your first little step into our notation on manipulating a function that we usually call that. All right, so what does it mean for two functions to be inverses? This is where composite functions, which we just got done working on, come into play. For two functions to be inverses, you need to combine them together in such a way that they undo each other. The way that works is you take the function f and you take the composite of it and its inverse. If you take the inverse of a function and plug it into the original function, something peculiar happens. It will simplify to just x. Not x plus 1, not x minus 3, not 2x, not x divided by 7, not -x. It'll simplify to just x. So a function is an inverse if and only if, that's what IFF is abbreviation for in mathematics, if and only if you take the composite of the two functions and it simplifies to give you x. Additionally, you can also do it in the reverse order. You can take f inverse of f of x, and it will also be equal to x. So you just need to prove one of them. You don't need to prove both. You take one of the two functions that you're curious if they're inverses of or not. You plug it into the other one, and if it simplifies to give you x, they're inverses. If it simplifies to give you anything else, they are not. Here's an example. I am going to determine if these two functions that I'm calling f and g, I'm going to determine are those inverses of one another or not. So I'm given a function f, I'm given a function g. They might be inverses, they might undo each other, they might not. The way I determine that is I'm going to either take the function f and plug it into the function g, or I take the function g and I plug it into the function f. Both are fine, both will get you the correct answer. I'm going to take the function g and plug it into the function f. Now, if these are in fact inverse functions, when I do this and I simplify this next equation I'm about to write, it should simplify to x. So this is going to turn into 2 times the quantity of the x value, which is the cube root of x plus 5 over 2, all minus 1, plus 1 cubed minus 5. So all I did is I replaced the x in the function f with the entirety of the function g. If these two are inverses, when I simplify this, I'm only going to be left with the x. All the other things, the cubing, cube rooting, the addition, the multiplication, the division, all of that will just disappear. Here's the nice thing about calculating if two functions are inverses or not. It will work out really cleanly. Like the first thing I notice is I have a minus 1 and a plus 1. Those two things eliminate each other. That means this would turn into 2 times the quantity of the cube root of x plus 5 all over 2, quantity to the third power minus 5. And what do you know? I'm just about to cube a cube root. The cube root and the cube undo one another. And you're left with 2 times the quantity of x plus 5 all over 2 minus 5. And now I'm about to multiply by 2 to something that I'm dividing by 2. So the multiplication of 2 and the division of 2 cancel out. And you're left with x plus 5 minus 5. And once again, the plus 5 and the negative 5 eliminate. So you're just left with x. So I simplified the composite of f and g, and I got that it's equal to x. Therefore, which is the 3 dot symbol, they are inverses. So I just showed you how to prove that two functions are inverses. Here's a very key and critical step in the main focus of today's lesson. I'm going to show you how to find the inverse now. Now there are two techniques. This is the intuitive approach. Later on, we're going to replace it with a more algebraic approach. The intuitive approach is nice because it ties to the understanding and definition of inverses. However, it does not always work. The algebraic approach always works, but it's a little more difficult to see exactly how or why it works. So here's how we find the inverse function. Problem number 1, I have f of x equals 2 times the cube root of x minus 1. I want to find that function's inverse. The way you find the inverse function for relatively simplistic problems like this is you do the inverse operation in the inverse order. So what I'm going to do is I'm going to imagine that I plug in a number for x, any number you want, and I'm going to work through mentally what would I do to that number and in what order. If I plugged in a number for x, the first thing I'd do is I would cube root it. So the first step is I would cube root. The next step after that, I would then, order of operations, I just did an exponent. Now I'm going to do multiplication. So I would multiply that value by 2. And then after that, we do the last step, which is subtracting 1. If you think about this like from a coding perspective, this is a list in order of what you would do to a number if you plugged into that specific equation. You would take that number, if you plug it into x, the first thing you do that number, cube root it. After you get that, you'd multiply that number by 2, then you take that number and subtract 1 from it, and you'd be done. We're going to make a new list of numbers now. This new list is going to be the same approach, just inverse operations. Instead of subtracting 1, we're going to add 1. Instead of multiplying by 2, we're going to do the inverse. We're going to divide by 2. Instead of cube rooting, we're going to cube. I put an x there just as a little placeholder. If I just put a 3, you really don't get the sense of scale. That a cube power is a little smaller. All right, so if I want to write the inverse function, what I'm going to do is I'm going to start with an x, and then I'm going to work through my inverse operations, and I'm going to do it in the inverse order. So I have my x, and the very first thing I'm going to do is I'm going to add 1 to it. Then after that, I'm going to divide all of that by 2. Then after I'm done with that, I'm going to take that entire thing and cube it. And here's the inverse function to f. I'm doing the inverse operations and the inverse order. Problem number 2, same thing. If I were to plug in a value for x, the first thing I'd have to do is I'd have to deal with the exponent, the second power. So the first thing I'd do is I'd square it. After that, after you'd square that number, you'd have to multiply it by 5. After we're done multiplying by 5, then we have to subtract the 3. And then lastly, the last thing you would do is you would divide by -7. So again, that is the sequence of steps you would take if you substituted in a value for x on getting the solution. Those are the step-by-step instructions on how to get from problem to answer. What we're going to do is we're going to generate a new chain that is going to be comprised of the inverse operations, and we're going to do it in the inverse order. Instead of dividing by -7, we are going to multiply by -7. It keeps the same positivity. You do not make negatives positives. You do not make positives negative. Only that only happens with addition and subtraction. Subtracting 3, we are going to add 3. Multiplying by 5, we are now going to divide by 5. Squaring is now going to be square rooting. All right, so for the function g inverse, the first step I'm going to do is I'm going to start with an x, and I'm going to go through this chain on the right side in the inverse order. So I'm going to multiply that x by -7. Then I'm going to take that -7x and I'm going to add 3 to it. Then I'm going to take that quantity and I'm going to divide it all by 5. And then I'm going to take that entire thing and I'm going to put it underneath a square root. And this would be my solution. Now, before I leave you off to do your own work, I do want to mention something that I have been harping on pretty much all year, that now we're going to take a slight change of pace from. In the past, I told you, when you introduce a square root, you have to put a plus or minus, yeah? Yeah. I introduced a square root, but I'm not going to put a plus or minus here, because what we're trying to do is create an inverse function. Plus or minus is not a symbol that exists for functions. Plus or minus is actually 2 equations, one positive, one negative. For inverse functions, you can't do a plus or minus. When we're creating inverses, or we don't care if they're functions or not, we just call them an inverse, then you would incorporate a plus or minus. So in this lesson, where we're making inverse functions, you can't use a plus or minus symbol. When we start going to like graphing, then you would include a plus or minus. So that's just a little side note that we will expand upon as the year progresses.